Hello everyone, welcome to the first lesson of your AMDEC chemistry class. You should have at this point printed off this handout inside the atom. If you haven't done so, please print it off and you can follow along with the lesson. So we've been talking about atoms and we're going to look at what's inside the atom. So inside the atom there are three subatomic particles. So the root of the word subatomic is atomic, so atoms. And sub, the prefix means within. So subatomic particles are particles that are within the atom. And you're probably familiar with these already. Protons, neutrons, and electrons. Protons have a positive charge. Neutrons have a neutral charge, so no charge at all. And electrons have a negative charge. Now as a shorthand, so you don't have to write the word proton all the time, you can use this symbol, P with a plus. Neutrons are N to the 0, and electrons are E minus. So those are little symbols you can use to represent those words so that you don't have to write them out all the time. And when we're talking about mass, we usually represent these in atomic mass units. So that's what the AMU stands for, atomic mass units. So what this means is a proton would have a mass of 1 atomic mass unit, and all the other particles are measured relative to the proton. So if the proton has a mass of 1 atomic mass unit, the neutron would be the same weight. It would also have a mass of 1. And the electron, well, it's much, much smaller. It weighs 1/2000th of a proton. So it's way smaller, and it's so small that when we're talking about the mass of an atom, which we'll see later, we really don't even consider the electrons. And when we're looking at where these are placed inside the atom, we're talking about either in the nucleus or in the orbits. More on that later. There's a few things on the periodic table that you need to know. The first one is the atomic number. So that's the one that tells you how many protons are in the nucleus of an atom. And the other thing is the mass number. It tells you basically the relative atomic mass in atomic mass units for the entire atom. So the mass is the sum of the protons and the neutrons. Because remember, the electron weighs so little, we don't even consider it when coming up with the mass of the atom. So, where can you find this information? If you haven't printed off the periodic table provided in the course resources yet, I would suggest you do that now so that you can follow along better. On the periodic table provided in the course resources, the element sections look like this, and you find this number here, that's your atomic number. And this number over here, that is your atomic mass. It's actually an average atomic mass because not all atoms of the same element have the same mass. So we take an average. So that's why you don't get a whole number here on your periodic table. But we can use these values to figure out how many protons, neutrons, and electrons are in an atom of any given element. If you want to know the number of protons, you simply find the atomic number, and it's the same. So in our example here, zinc has an atomic number of 30. That means 1 atom of zinc has 30 protons. And since the mass of an atom is the sum of the protons and neutrons, to find the number of neutrons, you just subtract the protons from the mass. And if the atom has an overall neutral charge, then the number of electrons has to be the same as the number of protons, because protons are positively charged and electrons are negatively charged. So those charges have to balance each other out. And it's very important to remember that every atom of an element has the exact same number of protons. That means every single atom of zinc has 30 protons. If you change the number of protons, you're talking about a different element. So let's work through some examples. We're going to look at how many protons, neutrons, and electrons are in an atom of each of these elements. So at this point, I'd like you to find your periodic table, get it out, and start looking for these elements. So we're looking for nitrogen, sodium, carbon, and uranium. Start by looking for the number of protons. Just remember, the number of protons is the atomic number. I would say pause the video right now and try to fill in this table, and then when you're done, you can unpause the video and check your answers. So I'm hoping you took the opportunity to try this on your own, and I'll show you the answers right now. The number of protons is just the atomic number. So there you go. It's just a matter of finding these elements on the periodic table. The number of electrons is the same as the number of protons. And the number of neutrons is the mass minus the number of protons. But let's move on to the rest of the lesson. So flip the page. Here we go. So how are electrons arranged in an atom? So we know that protons and neutrons are in the nucleus, and electrons are in the orbits. So remember, the nucleus is the central part of the atom where the protons and neutrons exist, and then there's these distinct orbits around the nucleus, and that's where the electrons exist. Now sometimes people will call these orbits shells. It means the same thing. I will probably use the word orbits instead of shells, but I'm just trying to make you aware of what different people would say from different sources. And these orbits around the nucleus, where the electrons exist, they represent different energy levels. So there are distinct levels of energy that electrons can have for each atom. Electrons in orbits closer to the nucleus have lower amounts of energy, and electrons in the outer orbits have a higher amount of energy. And electrons tend to be found in the lowest energy level possible, so that just means electrons won't leave the lower energy levels empty before they start filling up the next energy level. So when we're starting to draw diagrams, which we will in a moment, we always start filling from the inside and then we work out. Now each energy level, each orbit, can only hold a maximum number of electrons. The first orbit can hold 2 electrons. The second one can hold 8. And as we work further along in the periodic table, when you have more and more electrons, we'll get into higher energy orbits. For our purposes, we're just going to say that the third energy level can hold 8 electrons. However, this is only true when we're considering the first 20 elements. After that, it gets a little more complicated, which if you take grade 12 chemistry, then you'll learn more about that. But for our purposes, we're just going to stick with 2 electrons in the first orbit, 8 in the second, and 8 in the third. So that's the rule you got to remember, and we're going to move on and talk about how to actually draw these things. So the first thing we're going to look at is a Bohr-Rutherford diagram. So when the ideas of Niels Bohr and Ernest Rutherford are combined, we get a certain way of showing the structure of an atom. And this is the most common representation of atoms that you'll come into contact with. So it's important to know what they show and how you draw them. So 2 points, they show the number and location of protons, neutrons, and electrons. And they help us to identify why and how a particle will behave chemically. We'll get into that more when we talk about reactions. So let's look at carbon. If you find carbon on your periodic table, you need to find out how many protons and neutrons it has. Well, we already looked that up earlier. An atom of carbon has 6 protons and 6 neutrons. inside the nucleus. So that's how we start drawing these Bohr-Rutherford diagrams. Draw the nucleus. The next step is to start drawing in the electrons. So we're going to draw in the first orbit, and we know that we can only hold a maximum of 2 electrons on this orbit. So I'm going to draw them in. 1, 2. The first orbit is now full. Now I know that I have a total of 6 electrons, so that means I'm going to need to draw another orbit. So I'll go into the second orbit. Well, I already have 2 electrons in the first orbit. I just need 4 more electrons, so I'm just going to draw them in. 1, 2, 3, 4. And I always do that order of filling. I usually go top, bottom, left, right, top, bottom, left, right, and that just keeps me consistent. So when you're drawing these diagrams, you want to make sure that you don't put more electrons in an orbit than it can hold. So I'm okay here because I only have 4 electrons in the second orbit. It can hold up to 8. But I've got all 6 electrons in the orbits, 6 protons in the nucleus, and 6 neutrons in the nucleus. That's how I draw it. Now there is a shortcut I'd like to show you, and it's over here on your page. So if we're thinking about carbon, it's in the second row, so that means I draw 2 orbits. And it's in group 14, we look at the last digit, it's a 4. That means there's 4 electrons in the outermost orbit, the valence orbit. And that lines up with my diagram. I got 2 orbits, and I have 4 valence electrons. Now you can imagine if you're drawing Bohr-Rutherford diagrams for larger and larger atoms, it can get a little bit tedious. So thankfully, there is another way that we can represent atoms, and it's called Lewis diagrams. Basically, you write the symbol for the element, and then you put dots representing the valence electrons around the symbol. So remember, valence electrons are just the outermost electrons on the outside orbit. So I will show you sodium and magnesium, and then I'll let you try the rest. So sodium, the symbol for sodium is Na. When I look at sodium on the periodic table, it is in group number 1. That means it has 1 valence electron. Magnesium has a symbol Mg. It's in group number 2, so it has 2 valence electrons. And I do the filling pattern, top, bottom, left, right, top, bottom, left, right, until I have enough. So why don't you pause the video and try to draw the Lewis diagrams for the rest of these elements. Okay, here you go. I'll show you the Lewis diagrams. There you go. So you find the group number. For example, phosphorus is in group 15, so it has 5 valence electrons. If you have questions about how to draw these Lewis diagrams, please send me an email so I can help you out with that. Otherwise, if you're done this lesson and it all is making sense to you, you can move on to the quiz, which is next on your lesson outline.